All right, so today we're going to talk about polynomial and rational inequalities. So here we go. To solve inequalities, we're going to find the critical points. Okay, we're going to find the critical points. Then use the critical points to break our number line into segments. Test each segment. And this works regardless of whether it is a polynomial or a rational inequality. Okay, so let's talk about how to find the critical points. Okay, for a polynomial, specifically a quadratic, but it works with any polynomial, cubics included. We're going to solve it like an equation. So let's try one. Okay, let's try one. Here we go. Okay, solve x squared minus 5x plus 4 is greater than 0. Okay, we're going to solve this like an equation. So we're going to come over here and say x squared minus 5x plus 4 is equal to 0. And we can factor that into x minus 4 and x minus 1. And that's going to give us x equals 4 and 1. Now, this is an equation. These are not our solutions. These are our critical points. These are our critical points. So to find the critical points for a polynomial, we are simply going to solve it like an equation. That is the first step, step 1. Okay? Step 2, right? So step 1 appears, find the critical points. And then step 2 is to test each segment. So we're going to draw a number line. And on this number line, I'm going to put these two critical points, 4 and 1. Okay, so 1 and 4. You see this breaks our number line into 1, 2, 3 segments. You're going to pick a number from each segment and plug it in. Pick a number less than 1. I'm going to pick 0. Pick a number between 1 and 4. I'm going to pick 2. And pick a number greater than 4. I'm going to pick 7. Okay? We are going to plug each of these numbers into our original inequality. So if I plug in 0 here, plug in 0 here, I end up with 4 is greater than 0. That is a correct statement. So I come up here and put a check mark. If I plug in 2, 2 squared is 4. 5 times 2 is negative 10, so we get 4 minus 10 plus 4. I get negative 2 is greater than 0. That is a false statement. Put an X. Now 7. 7 squared is 49. 5 times 7 is 35. 49 minus 35 plus 4. I'll spare you the details, but basically what do we end up with? We end up with a true statement, and we put a check mark. So when we plug in 7, we end up with a number greater than 0. We end up with a positive value. I put a check mark. My solution is negative infinity to 1 union 4 to infinity. And that is this segment and this segment, but not this segment. Okay? So let's try another one. Okay, so number 2. Another example here. Solve. Okay? Solve. Let's try something like this. Let's try 3x squared plus 10x minus 8. And this time we're going to say is less than or equal to 0. Okay, less than or equal to 0. I'm going to come over here, and the first thing I'm going to do is I'm going to say 3x squared plus 10x minus 8 is equal to 0. Okay, and I'm going to solve this, and if you can factor this, it's great. It does factor into 3x minus 2 and x plus 4. And you can check that with the FOIL method and see that it gives you the original quadratic. If you cannot factor that and you use the quadratic formula, you will get the same two answers. And those answers are going to be x equals 2/3 and x equals -4. Okay, so 2/3 and -4. Your second step is going to be to put these critical points. These are your critical points, not your solutions. You're going to put these two critical points on the number line, -4 and 2/3. Notice I'm going to always put my numbers, my critical points on top, and then the numbers I'm trying, I'm always going to put on bottom. I'm going to try x equals -5, x equals 0, and x equals 1. Okay, so a number less than -4, between -4 and 2/3, and greater than 2/3. Okay, so I try those three numbers. When I plug in -5, I am going to get a number that makes this inequality not true. Okay, so when I plug in -5, right, -5 squared is 25, 3 times 25 is 75. That's going to be minus 50, so that'll be 25. 25 minus 8. That is not going to be less than 0. So I put a big X. How about if I plug in 0? We'll plug in a 0 here, plug in a 0 here. You get -8 is less than 0. That is true. And if I plug in a 1, I'm going to end up with 3 plus 10, 13, minus 8 is 5. 5 is not less than 0. That is a false statement. We get this. So what is our solution? Our solution is going to go from -4 to 2/3. Only this time we're not going to put parentheses. This time, because we had less than or equal to, we're going to put brackets. Okay, brackets. So this is our final solution. Okay. And I'm going to go ahead and show you guys, if you solved a bunch of these, you're going to find out that greater than inequalities usually end up with the two outer segments true, and less than inequalities usually end up with the inner segment true. That's not always true, but it's true quite a bit of the time. So you should feel pretty comfortable if that happens, but always do check these numbers. Okay, let's try one more. Okay, let's try one more. Okay, one more. And again, we're going to solve this. So let's take x squared plus 6x minus 1. And we're going to say this is less than 0. Okay, so this will be parentheses, not brackets, because it doesn't have that equal to. And if we set this as an equation, 6x minus 1 equals 0, this does not factor. Go ahead and write that out for you. This does not factor. Okay, does not factor. No way, not going to factor. Okay, so if this doesn't factor, what's my choice? My choice is the quadratic formula, which is going to be the opposite of b, plus or minus b squared minus, and I'm going to go ahead in my head and say 4 times a times c. Well, 4 times 1 times -1 is plus 4, and that's all over 2a, and that's going to give me -6 plus or minus, this is the square root of 40, which is 2 root 10 over 2, which is equal to -3 plus or minus root 10. -3 plus or minus root 10. Okay, now that is a great math answer, but when I come over here and draw my number line, I'm going to put -3 minus root 10, and I'm going to put -3 plus root 10. And that's great. Those are really pretty math answers, but they don't help me to pick numbers to plug in. So I'm going to help you guys out. I'm going to tell you that -3 minus root 10 is -6.16, and -3 plus root 10 is positive 0.16. And so I'm going to pick -7, 0, and by the way, always pick 0 if you can because it's just easier. And then a number bigger than 0.16, I'm going to pick x equals 1. I'm going to take a second to just make sure you guys understand. I could absolutely pick -5 here. I could absolutely pick -2 here. Here I could pick 2, 3, 4, 5, 10, 20, 50, anything bigger than 0.16. Okay, so make sure you understand that. Now, we're going to plug these in. If I plug in -7, -7 squared is 49. 6 times 7 is 42, so positive 49 minus 42 is going to be 7. 7 minus 1 is 6. 6 is not less than 0, so that doesn't work. If I plug in 0, 0 here, 0 here, I get -1. -1 is less than 0. It works. And if I plug in positive 1, I get 1 plus 6. That's 7. 7 minus 1 is 6. 6 is not less than 0. That does not work. What's my answer? My answer is between that number and that number on the number line, which is going to be -3 minus root 10, comma, -3 plus root 10 in parentheses. And they're in parentheses because this was less than and not less than or equal to. Okay? All right, so now let's do rational inequalities. For rational inequalities, we must have one fraction and set it equal to 0. Okay? Then see what values make the numerator and denominator equal to 0. Those are my critical values. Okay? Those are my critical values. And what do we do with our critical values? We test them on the number line just like we do for quadratic inequalities. So here we go. I'm going to give you some problems. Solve number 1. X minus 4 over x plus 3 is greater than 0. Okay? So what do we got? We've got one fraction on one side, 0 on the other. We're good. Then we need to see what values make the numerator and denominator 0. So we say, okay, x minus 4 is equal to 0, and we say x plus 3 equals 0. So set the numerator equal to 0, set the denominator equal to 0. This is going to give me x equals 4, and this is going to give me x equals -3. Those are my critical values. Now, we're going to take our number line, and we're going to put our 2 tick marks, and we're going to put -3 and 4, -3 and 4. And just as an aside, folks, make sure your lower number is on the left of your number line so that it's accurate and correct. Thank you. Pick some values. I'm going to pick x equals -5. I'm going to pick x equals 0. I'm going to pick x equals 5. That easy. Okay, now, here we go. We're going to plug this in. What do I get? If I plug in -5, -5 minus 4, I get -9. And if I plug in -5, -5 plus 3 is -2. Is -9 over -2 greater than 0? Well, -9 over -2 is positive 4.5. 4.5 is greater than 0. I put the check mark. Same thing for 0. We're going to plug these in. I get -4 over 3. That is not true. Plug in positive 5. 5 minus 4 is 1. And 5 plus 3 is 8. And 1/8 is greater than 0. So we put a check mark. And there's our answer. Our answer is parentheses -infinity, -3, union 4 to infinity. Okay? That's it. And I will give you a little trick, folks. If you get two negatives, they're going to make a positive. They'll always be greater than 0. If you get two positives, they'll be positive and greater than 0. And if you get one negative, top or bottom, doesn't matter, it'll be less than 0. And this will be a false statement. Number 2. Let's try one more here. Okay? What if I give you 4 minus 2x over 3x plus 4? And this one is going to be less than or equal to 0. Okay? So if I give you that, again, what's our deal? We have to have a single fraction, 0 on the other side. We have that. We're going to say 4 minus 2x is equal to 0, and we're going to say 3x plus 4 is equal to 0. Set our numerator and denominator equal to 0. Solve this, and you get x equals 2. And solve this, you get x equals negative 4/3. Those are critical values. Those are going to go on our number line. Here's our number line. I'm going to say negative 4/3. And I'm going to say 2. Pick a number, pick a number, pick a number. I'm going to pick x equals 5. I'm going to pick x equals 0. And I'm going to pick x equals negative 2. Okay, just because I can. You could pick negative 3, you could pick negative 5, you could pick 10. Here you could pick 3, 4, 5, 10, whatever you want to pick. Just has to be bigger than 2 in this case, and has to be smaller than negative 4/3 or negative 1 1/3 in this case. Okay, plug in negative 2. Okay, what is 4 minus 2 times negative 2? Well, 2 times negative 2 is negative 4. 4 minus negative 4, that's going to be 8. Okay, so I'll just write that down for you. That's 8. Okay, how about negative 2? 3 times negative 2 is negative 6. Negative 6 plus 4 is negative 2. What's 8 divided by negative 2? Well, it's going to be negative. Any negative number is less than 0, so that's going to work. Okay, cool. How about 0? Plug in 0. What do you get? You get 4 over, plug in 0 here, you get 4 over 4. 4 over 4, 1. Is 1 less than 0? Nope. And then plug in 5. 2 times 5 is 10. 4 minus 10, hopefully, is negative 6. And 3 times 5 is 15. 15 plus 4 is 19. Negative 6 over 19 is a negative number. A negative number is less than 0. So this works. Our solution is negative infinity to negative 4/3. Oh, I goofed. Almost goofed. We get a bracket because this is equal to union bracket 2 comma infinity. Almost goofed there. And that would be bad because I'm writing in pen. Ugh, math and pen. This is why you're not supposed to do math in pen, right? So anyway, guys, that is rational inequalities. The only wrinkle you might get with one of these is if you had more than one fraction, you would have to move that quantity over and combine those two fractions. Okay, not a lot of those in your book, but that's the one wrinkle you would have. This method only works if you have a single fraction. So anyway, guys, that is rational inequalities and polynomial inequalities. Please let me know if you have any questions, and make sure you get your homework done, and we'll see you next week.